Hi, today I'm going to do an example for volume of solids of revolutions using Washer method. So consider a region bounded by an outer radius, I denoted big R of x, and an inner radius denoted little r of x. The formula for the volume of solid revolution in Washer method is V equal pi times the integral from a to b times the outer radius square minus the inner radius square dx. Okay. So let's take a look at the example. So I want to find the volume of the region bounded by the function y equal x, y equal 3, and x equals 0, and is revolving around the horizontal line y equal 4. So first thing first, let's sketch the graph. Okay. It's going to be in the first quadrant, so I don't care about the other quadrant. Like that. And then y equal x is, oops, y equal x looks like that. It is in light blue or ocean blue. And y equal 3 is, maybe put it right here. And then x equals 0, that's just the y-axis. Okay, that's just the y-axis. So it's right on the y-axis. Okay, and then it's revolving around the horizontal line y equal 4. Maybe I'll put it here. Y equal 4. So here is y equal 4. This one is y equal 3. And this one is y equal x. And here is x equal 4, right? And suppose I want to rotate the region, the region with between the function, which is this region here, just this region right here, around the horizontal line y equal 4, right? Around this line. Draw that line. Okay. So let's pick an arbitrary x. Let's pick an arbitrary x and give it some depth and width. Okay. So here I have dx. So imagine if I sweep the slice around the y equal 4, visually it looks like this. Visually it looks like this. It looks like a disk with a hole in between. So the outer function, my outer function will be the blue one, and the inner function will be the pink one. And the line y equal 4 it's in between. Try to be neat so you can see the picture. Oops, sorry about that. All right. So my slice dx is right here on the disk. It's dx. Okay. So again, in order to find the volume of these solids of revolution, we need to find what is the outer radius and what is the inner radius, and the bounds of the integral. right? So what we're doing here is that we can figure out one of these washer for a given x, and then we just have to sum it up all of the washer for all of the x's in our interval. Okay, so let's do that. So first, let me find what is the area of the washer. So first, I want to find the area of the washer, which is equal to the outer radius, r of x squared, right? Minus the inner radius, which is little r of x squared. Maybe make it in bracket. Okay, so in order to find this region in between here, my outer radius will be this one here, right? And subtract the inner radius, which is this one here, right? In order to find what is in between all that region right there, right? So r of x, the big R of x is going to be equal to the blue function, which is x, minus the axis of rotation minus the red, right, which is 4. And then of course you square that, right? Subtract the inner radius will be equal to the pink function, which is 3, minus the red, which is 4. And of course square that. Right? So again, let me denote. So x will be your the blue function, 4 is your axis of rotation, and 3 is that pink function there. Okay. So let's clean this up a little bit. It's equal to, if I FOIL that out, if I FOIL the x minus 4 squared, I have x squared minus ax plus 16 minus 1, or x squared minus ax plus 15. Okay. So that's r of x, big R of x squared minus a little r of x squared. The limit of the integration integration is, let's see, it's going to be from 0 to where? To here, right? To here. That's where the function y equal 3 and y equal x meet. So be 3. So if you set those two equal to each other, so if I set, so let's do a little here. If I set x equal to 3, right? So my upper limit will be 3. Okay. Right. So we have area, we have the limit of integration. All you gotta do is just plug in this formula right here. So the formula, volume of a solid revolution, V equal pi integral from 0 to 3 of, let's see, I'm gonna rewrite this for you. Big R of x squared minus little r of x squared dx. Right, and then I'm gonna substitute the numbers in. Big R of x squared minus r of x squared, we calculated at x squared minus ax plus 15 dx. Right. So now all we have to do is to evaluate this integration. Okay, so equal pi. Antiderivative of x squared will be x cubed divided by 3 minus 4x squared plus 15x. And evaluate as from 0 to 3. I'll do in red so you can see the limits. Right, let's plug in the upper limit first. So whenever I see an x, I replace it with 3. So I have 3 cubed divided by 3 minus 4 times 3 squared plus 15 times 3. And then when I subtract the lower limit, if I replace the 0 for every x here, I just get 0, like one big nice 0. So let's see, let's calculate what is this quantity here. 3 cubed is 27 divided by 3 is 9 minus 4 times 9 is 36 plus 15 times 3, that's 45. So I have 18. So my answer will be 18 pi cubic units. So this is the final answer for the volume of that washer.